you are all set. You want to just...
Yes. Hello, my name is Alicia Juarrero, and I'd like to thank the organizers of the Saturn Conference and Bob Russell in particular for inviting me. I think my job is to explain the bubbles. My background is philosophy, and I'm going to keep my remarks to the philosophical realm. And what I am interested in is primarily the notions of self-determination, autonomy, and agency. The first sentence of my book was, what's the difference between a wink and a blink? And the reason that's important is because you can be held morally responsible and legally liable for winks, but you can't for reflex reactions like blinks. And so the whole notion of agency and morality depends on being able to make this distinction. Nothing happens? Which one?
This one here.
Oh, okay, that one? No?
Sorry. Sorry about that, Alicia. Let's go back a second. Adrian, I might need you again. Now we're in a loop. I think we shouldn't have that bottom.
Do you want me to start?
Yeah,
anyway?
please
All right.
go ahead. Sorry.
I'll wing it. I'll start with part of where Bob was leaving off, and that is modern science makes a whole lot of assumptions. Oh, thank you. That really cause self-determination, agency, and autonomy to be rendered very problematic. One of the issues that implicitly you brought out was the notion that all causes reduced to efficient cause, billiard ball kind of causes, and if you're thinking of questions such as agency and what makes an action really a self-determined action, then how on earth are you going to explain the way an intention causes behavior in any kind of efficient causal way? But one thing that is often pointed out, but one thing that is rarely pointed out is that although we discarded the notions of formal and final cause from Aristotle, we did keep the notion that nothing causes itself, that the idea that something can cause itself is not allowed in modern science. That is particularly problematic when you're thinking of, we think of parts interacting to produce wholes, which in turn constrain their parts. That is not allowed. The whole as such is not allowed to affect its parts. So it's particularly problematic for top-down causation. And part of the reason for this is that in modern science, wholes are considered nothing more than aggregates. They have no emergent properties on their own, and in particular, they are epiphenomenal as aggregates. They have no causal efficacy to act especially on themselves. So as soon as you have that, what happens? Self-determination, autonomy, and agency go out the window. That's why you end up with dualism. You have to have dualism because if nothing can cause itself, then you have to have one thing that causes another, and that one thing has to be then non-physical. That gets you into trouble with the other part of science, which says that conservation of matter and energy. So you've got all that whole history in philosophy of mind that comes out of that. Oh, well, so let's not use a non-physical mind or an intention. Let's make it all material. So then it's going to be a whole bunch of neurons that cause behavior. Yeah, where are you going to get meaning from? How are you going to explain how this wetware, where does meaning come out of if it's all materialistic? So this is where traditional modern science really boxes you in a corner and doesn't let you explain notions of agency. Now, this is not news. Immanuel Kant was very much aware of this at the end of the 18th century. He points out in the third critique, when he's looking at living things, he says, well, you know, living things are really constituted by a kind of causality, and then he says it's unknown to us. Why? Because he's dealing with a Newtonian Humean historical context. The example he gives is a tree is produced by the leaves, but in turn produces the leaves. So you've got parts interacting to produce the entire organism, which then produces the very parts that produce the whole. So you've got this recursive phenomenon going on. He says, we have no way of dealing with this. And my first paper that I published had to do with this issue way back before complexity was cool. I always say I was interested in complexity before it was cool. Because the questions we were asking is, how do coherent unities emerge? What kind of science can talk to us about the emergence of coherent unities that are able, not through efficient causes, formal cause, to act on themselves? And so in the 19th century, you get all sorts of attempts to answer these. You get Bergson's talking about an élan vital. You get Polanyi talking about how the patterner creates the pattern, and the pattern in turn produces the components. But if you look at them very carefully, they're still following a very modern science approach. They're still assuming that nothing can cause itself, that you have to have causality come from outside somehow. But lo and behold, what attracted me to complex dynamical systems theory was precisely this ability that is described, that Prigogine gets the Nobel Prize in '87 for the notions of physical dissipative structures, and those are the bubbles, right? You've got a pan of water, you heat it from below, after a certain temperature, you get a phase transition so that these coherent hexagonal cells begin to form in the pan of water. Now, what's interesting is that once a molecule of water is caught up in one of these bubbles, the whole of the bubble constrains the direction and the behavior of the component part. So you have sort of an incipient proto-beginning of how to account for the way a whole constrains its parts. And notice I sneakily changed from the word cause to the word constraint, because unfortunately the word cause has now been equated with efficient cause, and that's all anybody thinks of. But the thing about physical dissipative structures, even though this is the discovery of how these open, far from equilibrium structures form and so on, is that the boundary conditions are set from without, right? The boundary conditions are set by the scientist who chose the shape of the pan, the water, and so on. But what happens is that once you get to the chemical level, you get something very interesting going on, and you get autocatalysis, where sketchily, crudely, A, say, catalyzes B, which catalyzes C, which lo and behold loops back down and catalyzes A. But what's interesting about a catalyst or feedback, it's the same mechanism, is that they both exemplify constraints. And if you think of a constraint as a change in the probability distribution, so a catalyst speeds up a process, it makes it more likely, correct? And so the curious thing about autocatalysis is that the boundary conditions within which this structure organizes is produced by the workings of the endogenous dynamics themselves. It's not produced by an outside agent, like whoever chose the size of the pan or whatever. So that what I find very attractive here, again, I've got agency in mind, is that you have a way that this kind of science, unlike mechanistic Newtonian science, gives me a way of understanding how, through the workings of context-sensitive constraints, one thing, given catalyst A, B is more likely, given B, C is more likely. And once you have closure of context-sensitive constraints, what happens is that there is suddenly the emergence of a novel global order, which is really a second order, higher order constraint that can then loop back down and affect the components that go to make it, affects the constraints that go to make it up. So you have, remember Hofstadter's choice of terms, strange loops. It really is a strange loop phenomenon where local constraints interact, and when they close, you get an emergence of a global constraint that has emergent properties. And this occurs at almost at every level that this happens. In the case of a bunch of amino acids, think of them, and they interact, and you get the emergence of protein function. Right? Which has, but in turn, these emergent properties have constraint, if you will, are able to constrain the components that make them up. And so what is interesting is that it's the emergent qualities at the higher level in terms of which that constraint on the lower level get carried out. So that gives me a way of scientifically, legitimately understanding the notion of whole part complaint, which wasn't available before the development of complex dynamical systems theory. So what this gives me is a way of understanding autonomy, because from chemical autocatalysis on up, it's the endogenous dynamics that are responsible for producing the global order. So it's an autonomous, it's a self-organized, autopoietic structure in the sense of Varela and Maturana and Varela. It gives me an understanding of what agency is, because I can say that an action, in the sense of a wink, not a blink, an action is behavior that issues from that top-down constraint in terms of its higher properties. And it gives me a way of understanding self-determination, because the properties, the emergent properties that constitute the agent and the agency are the source of the behavior. So it really gives me a way of looking at things that it's perfectly scientifically respectable now. I don't have to appeal to an élan vital here in this case. But to get back to the theme of the conference is, what you have is almost a loosening of determinism every time you have a new emergence, because each time you have new emergence, you have, in a sense, an enlargement of the phase space, a creation of information. So you almost have an ongoing creation that is occurring, and freedom opening up at each sense. And curiously, if you look at it, it's as if the locus of control gets pushed upwards at each step along the way, because at each step along the way, if it's the emergent qualities that are selecting among the components to actualize one rather than any of the others, then the behavior is under the control of meaning or values or whichever the emergent property is, and not at the mercy of energetic processes with which they are obviously compatible. Nobody's violating any other laws, but with which they are compatible. So this is what I've been working with for going on 30 years now, and I think it's very exciting, because it gives me a way of handling these issues that wasn't available before. Thank you. Yes, you want to go? Yeah. Oh, you're good. You call me. Yeah.
Very interesting. So the autocatalytics, you get order and constraint. Can you say anything about information and intentionality, the next step?
Well, I think an intention is, with meaning, with awareness, is one of these emergent properties of self-organized neuronal patterns, and it's the emergent pattern that then is constrains the behavior such that the behavior carries out, in Searle's term, the semantic content of that intention. Because I intend to do X, and it's the X that is the semantic content, right? And in a sense, that's the emergent property because the wetware doesn't have semantic properties. That's my hypothesis. That's my claim. Yes, here and then there. Thank you.
Okay. I'll go back to the Munchausen trial on Carl Albert, that to justify something, you have to go to first cause or infinite regress or circularity. None of them are highly satisfied, but you do the best. So what I suggest here is that, in fact, circularity is what you're sort of assuming there, but you're not formally assuming that. And I would just say, in terms of string theory really comes out of nuclear democracy, where all the particles are equal.
Nuclear democracy.
And
I like
saying everything in the universe causes everything else, and then we're going to break the symmetry to match, the asymmetries we see, seems to be the way we should go.
In a sense, what you have here is the local constraints close, and then you have an emergent property that then loops back down. So it's circular, but it's also almost a spiral. So you're operating at two simultaneous domains of constraints. You've got the horizontal, but you've got the temporal one that also includes a different level. Thank you. Yes?
So could you link this back to indeterminacy and genetic structures in the way evolution can take place? Getting back to Bob Russell and Nyota and all of that, it seems to me these endogenous feedback mechanisms are precisely what you're talking about.
Well, and I think that every time you have a self-organized structure that emerges, it's almost from a philosophical point of view, the emergence of a type, of types. But what's typical about a type is that it is multiply instantiated or instantiatable, multiply realizable, philosophers say, by various tokens. So you have variability and choice opening up as to which gets instantiated at each step along the way.
Thanks, Alicia.
Thank you.